All right, folks, get ready for a seriously wild ride because today we're going deep, and I mean deep, into some ideas that'll challenge how you think about reality itself. If you're into having your mind blown wide open, you are definitely in the right place. And hey, while you're at it, hit that like button and subscribe so you don't miss out on future deep dives that'll make your brain do backflips.
I have a feeling this one's going to be a real doozy.
No doubt about it. We're tackling the work of David Deutsch. This guy's a physicist who's not afraid to shake things up, to say the least. We're talking quantum computation. We're talking about rethinking the very foundations of knowledge. But the real mind blower is his argument for the multiverse.
Yeah, you heard that right.
Parallel universes, folks. Get ready to explore the idea that every possibility, every path not taken might actually exist somewhere out there.
It's a concept that pushes the boundaries of what we thought was possible, and yet it's grounded in some of the most cutting-edge science we have. Quantum mechanics.
Okay, so before we jump headfirst into the multiverse, let's lay some groundwork here. One of the things that really struck me about Deutsch is that he starts with a pretty radical idea. He thinks empiricism, the idea that all knowledge comes from our senses, is flat out wrong.
You're picking up on something really important there. Deutsch argues that the foundation of knowledge is actually good explanations. And not just any old explanation, mind you. He's talking about explanations that are hard to vary, meaning you can't really change them without the whole thing falling apart, and they have to connect to a wider web of understanding.
So it's not just about observing the world around us, but about coming up with explanations that fit those observations perfectly, like a key in a lock, and that link up with everything else we know about how things work.
Precisely. And Deutsch gives this great example using something we all experience, the changing seasons. So think about how we explain the seasons scientifically. It's all about the Earth's tilt, its orbit around the sun, how those factors influence sunlight on different parts of the planet. It's really hard to vary this explanation because each piece is so crucial.
Right, you can't just throw in some random idea like maybe the Earth's doing a little dance and that's why it gets cold in the winter.
Yeah.
It just doesn't hold up as a good explanation.
Exactly. Now, contrast that with, say, a mythical explanation for the seasons, like that ancient Greek story of Persephone. It's a great story, no doubt, but you could change a lot of the details. Maybe Persephone decides she actually prefers the underworld, and it wouldn't change the actual phenomenon of the seasons.
Yeah, because it's not really explaining why things happen the way they do.
Exactly. It's a description, but not a good explanation.
So the scientific explanation is like a finely tuned machine where every part is essential, while the myth is more like a flexible story that doesn't really get at the underlying causes.
That's the heart of Deutsch's point. And here's where things start to get really interesting. He argues that this same principle, the importance of good explanations, applies to something way more complex and mysterious: quantum mechanics.
Now we're stepping into the truly weird and wonderful, right? Quantum mechanics has a reputation for being notoriously strange and counterintuitive.
Oh, absolutely. But Deutsch suggests that maybe the weirdness is only a problem if we're clinging to bad explanations.
So instead of facing the truly bizarre implications head on, we try to come up with interpretations that make it more palatable, more in line with our everyday experience.
You got it. And Deutsch isn't afraid to dive right into the deep end of weirdness, which leads him to this mind-blowing concept of the multiverse.
Okay, let's talk about the elephant in the room. Or should I say the infinite elephants in the infinite room?
Yeah.
The multiverse. What exactly are we talking about here?
Think of it this way. Quantum mechanics shows us that at the subatomic level, particles can exist in multiple states at once. This is called superposition. It's like a coin spinning in the air. It's not heads or tails until it lands. It's both, potentially.
Okay, got it. Superposition, particles being in multiple states at once. But how does that connect to parallel universes?
Well, instead of saying the particle state is undecided until we measure it, the multiverse interpretation says each possible state actually exists, but in a separate universe.
So going back to the coin, it's like there's one universe where it lands on heads and another where it lands on tails, and both of those universes are real.
That's the basic idea. It's not that reality is fuzzy or undecided, it's that reality is constantly branching out, encompassing all possibilities. Every time a quantum event could go one way or another, a new branch of the multiverse is born.
Hold on, so are you saying that every time I make a decision like, do I have coffee or tea this morning, there's another me in another universe making the opposite choice?
You're catching on quickly. That's one way to think about it. Every decision, every quantum event splits reality into these multiple branches, each representing a different outcome.
Okay, my brain is doing somersaults right now. But if there are infinite me's out there, how come I'm only aware of this one?
Think of it like separate movie screens. You can only watch one movie at a time, even though there are countless others playing simultaneously. You're only aware of your own branch of the multiverse, your own unique timeline, so to speak.
Okay, I think I'm starting to get the concept, but it's still a lot to process. Is there any evidence to back up this crazy idea, or is it all just theoretical speculation?
Well, that's where things get even more interesting. Deutsch actually points to several lines of evidence, including one that's particularly relevant today: quantum computing. Quantum computers, unlike our everyday computers, can actually use superposition to perform calculations across multiple universes simultaneously.
Wait a minute, are you telling me that quantum computers are tapping into the power of parallel universes to solve problems? That sounds straight out of science fiction.
It does sound like sci-fi, I'll grant you that. But the implications are very real. The fact that quantum computers work, and they do, albeit in their early stages, suggests that the multiverse isn't just some theoretical fantasy. It might actually be the best explanation we have for how these incredible machines function.
So the multiverse interpretation not only helps us make sense of the strangeness of quantum mechanics, but it also has practical applications in cutting-edge technology. That's mind-blowing.
It is, and we've only just scratched the surface here.
Yeah.
Deutsch also uses this thought experiment called the transporter malfunction to illustrate some even weirder aspects of the multiverse, like something called fungibility and how histories can branch.
Okay, now you've really got me intrigued. Transporter malfunction. This sounds like we're beaming into some serious Star Trek territory. And I, for one, am ready to boldly go where we haven't gone before. But for now, I think our listeners might need a moment to digest all this mind-bending information.
I think that's a good idea. It's definitely a lot to take in. But stay tuned, because in the next part of our deep dive, we're going to explore that transporter malfunction and really delve into the philosophical implications of the multiverse.
And until then, keep those brains buzzing, folks. And if you haven't already, make sure you hit that like button and subscribe for more mind-expanding deep dives. Welcome back, everyone. We're picking up right where we left off, exploring the mind-bending world of David Deutsch's Multiverse. Get ready to have your neurons stretched as we grapple with a thought experiment that'll really challenge how you think about identity.
Yeah, this one's a real head-scratcher, but it does a brilliant job of illuminating some of the most profound and perplexing implications of the multiverse.
You piqued our curiosity with this transporter malfunction idea. Sounds like something straight out of Star Trek. But I have a feeling this is going to be a lot more philosophically complex than your typical sci-fi scenario.
You're absolutely right. Deutsch uses this thought experiment to explore some really deep questions about identity, about individuality, about the nature of reality itself. So picture this: a starship with a transporter, just like in Star Trek, but in this case, something goes wrong. Instead of transporting the person from point A to point B, it creates two identical copies, one in the original universe and one in a parallel universe.
So it's not moving someone, it's actually duplicating them across realities. That's already pretty wild.
It is, and it gets even weirder. Initially, these two copies are totally identical, same memory, same experiences, everything. Deutsch calls this fungibility.
Fungible, like those dollar bills we all carry around. Interchangeable.
Exactly. You could swap one for the other and it wouldn't make any difference. But here's where Deutsch throws in a twist. He introduces a voltage surge that affects one of the copies, but not the other.
So now we've got two versions of the same person, but one of them has been slightly altered by this surge.
Precisely. And because the laws of physics in this hypothetical multiverse are symmetrical, there's no way to predict which copy gets zapped. It's totally random.
Okay, I see where this is going. This ties into the idea of branching timelines, right? We now have two distinct histories, one where the person experienced the surge and one where they didn't, all stemming from this random event.
You got it. This highlights how even the tiniest difference can lead to a divergence in timelines, creating a whole cascade of unique histories.
It's like that saying, for want of a nail, the shoe was lost. For want of a shoe, the horse was lost. A small change can have massive ripple effects.
That's a great analogy. And in the multiverse, those ripples spread out across countless realities, weaving this tapestry of infinite possibilities.
This brings up a question that's been bugging me. If every quantum event, every decision creates a new branch, does that mean we're surrounded by countless versions of ourselves, all living out different possibilities?
In a way, yes. But remember, we can only interact with those versions that share our history, those within our particular branch of the multiverse.
So, no chance of bumping into my evil twin from a parallel dimension.
Not very likely. As far as we know, there's no way for information to travel between these parallel branches.
Probably for the best. But if we can't communicate with these other versions of ourselves, how can we even be sure they exist? Isn't this whole multiverse thing just a theoretical construct?
That's where quantum mechanics comes back in. This phenomenon called quantum interference, the way particles act like waves and interfere with each other. That provides some pretty strong evidence that the multiverse is more than just a theory.
Okay, remind me about quantum interference. It's been a while since I cracked open a physics textbook.
Sure, imagine shining a beam of light through two slits. You'd expect to see two bright spots on a screen behind it, right? But what you actually get is this pattern of bright and dark bands, an interference pattern. This happens because the light waves passing through the slits interact with each other.
So like ripples in a pond, they either amplify or cancel each other out depending on how they collide.
Exactly. But here's the mind-blowing part. This interference pattern also shows up when you fire single particles, like electrons, through the slits one at a time.
Wait, hold on. How can a single particle interfere with itself? That doesn't make sense.
It's one of the biggest mysteries of quantum mechanics. The only way to explain it is to accept that the particle somehow passes through both slits at the same time, like it exists in multiple states simultaneously. And this is where the multiverse interpretation comes in. It offers a really clear and consistent way to understand this otherwise baffling phenomenon.
So instead of trying to picture this single particle being in multiple places at once, we can think of it as multiple copies of the particle, each existing in a different universe, and those copies are what's interacting with each other.
That's it. That's the beauty of the multiverse interpretation. It neatly resolves a paradox that's been stumping physicists for generations.
Okay, that makes sense on a microscopic level, but how does this impact us in our daily lives? It's not like I feel myself splitting into multiple versions every time I make a choice.
Well, that's because the effects of quantum interference are usually too small to notice in the everyday world. But there are situations where these effects become more apparent, especially in carefully controlled experiments, and, get this, in emerging technologies like quantum computing.
So the fact that we can build and operate quantum computers, devices that actually take advantage of quantum superposition and interference, is that further evidence that the multiverse is real?
You bet. The algorithms that power these computers, they rely on these principles. They wouldn't work if the multiverse wasn't a fundamental aspect of reality.
This is just incredible. I mean, now I'm really curious about these quantum computers. How are they tapping into the multiverse to do these calculations?
Oh, that's where things get really fascinating. Instead of bits, which can only be either a 0 or a 1, quantum computers use these things called qubits. And a qubit can be in a superposition, meaning it's both 0 and 1 at the same time, like that coin spinning in the air, holding both possibilities at once.
So each qubit is basically exploring multiple possibilities in different universes simultaneously.
That's a great way to think about it. And because of this, a quantum computer, even with just a small number of qubits, can explore a massive number of possibilities all at once. It's like having an army of parallel processors, each working on a different part of the problem in a different universe.
This is blowing my mind. So what kind of problems can these quantum computers solve that our regular computers can't even touch?
One of the most promising applications is in cryptography. Our current encryption methods rely on these complex mathematical problems that are really difficult for classical computers to solve. But a powerful enough quantum computer could crack those codes in a fraction of the time, making them essentially useless.
Wait a minute, are you saying quantum computers could break the internet?
Potentially, yes. But the good news is that quantum mechanics also offers new ways to create codes that are basically unbreakable. It's kind of an arms race right now, with researchers developing both quantum computers and quantum cryptography techniques.
Wow, it sounds like we're on the cusp of a technological revolution. And it's all thanks to the weirdness of quantum mechanics and the potential of the multiverse.
Absolutely. And this is really just the beginning.
Yeah.
Quantum computers have the potential to revolutionize so many fields: medicine, material science, artificial intelligence, you name it. We're just scratching the surface of what might be possible.
It's like we're peering through a doorway into a whole new realm of possibilities. This multiverse idea is starting to feel less like science fiction and more like the future of science and technology.
Exactly. And it all goes back to Deutsch's core idea. Good explanations are the key to unlocking new knowledge and new possibilities. By embracing the strangeness of quantum mechanics and this mind-bending concept of the multiverse, we open ourselves up to a universe of potential. Literally.
I have to admit, thinking about all of this, the sheer scale and complexity of the multiverse, it can be a bit overwhelming. It's exhilarating, but also a little bit terrifying.
I understand. It challenges how we usually think about reality and our place in it. But that's what makes it so exciting. It forces us to confront our assumptions and expand our understanding of what's possible.
And speaking of expanding our understanding, we still need to unpack that fungibility concept you mentioned earlier. It's a real brain twister.
I agree, it's a key piece of the puzzle. Remember those two copies from the transporter malfunction thought experiment?
Yeah, identical down to the last atom.
Right. But as soon as that voltage surge hits one of them, they're no longer fungible. They become distinct individuals with their own separate histories.
So fungibility is about potential then. As long as two things are completely identical, they're fungible. But any difference, no matter how small, breaks that fungibility and sets them on these divergent paths.
You got it. And this helps explain why we experience this single, consistent timeline, even though the multiverse is constantly branching off into all these infinite possibilities. As long as those versions of ourselves remain fungible, they're basically indistinguishable from our perspective.
So it's only when a difference arises, a choice is made, a quantum event happens, that a new branch of reality becomes distinct and separates from our own.
Precisely. And these differences can come from anything. A quantum fluctuation, a decision we make, even something as mundane as spilling your coffee.
Wait, spilling coffee, that seems a bit trivial to trigger a split in the multiverse.
It might seem that way, but remember what we said about the power of small differences. In the multiverse, every event, no matter how insignificant it might seem, has the potential to create a whole new branch of reality.
So there could be a universe out there where I didn't spill my coffee this morning, and maybe that version of me is having a much better day?
It's entirely possible. But even if that version of you exists, you'll never meet them, and they'll never meet you. You'll both continue along your own unique timelines, shaped by the choices and events that unfold in your own branches of the multiverse.
I think I'm starting to wrap my head around this, but it's a lot to take in.
It is. But I think it's worth the effort. The multiverse interpretation offers a profoundly different and, in my opinion, more accurate view of reality than that limited perspective we're used to.
I agree, and it definitely makes for a fascinating conversation. We've covered so much ground already, from the philosophical foundations of Deutsch's ideas to the implications of the multiverse, and even touched on quantum computing.
It's been quite a journey. Deutsch's ideas are full of insights and challenges, and I really hope our listeners will dig deeper into his work and keep exploring the implications of the multiverse for how we understand reality.
I couldn't agree more. And speaking of exploring implications, you mentioned earlier that Deutsch's multiverse is different from other multiverse theories out there. Can you tell us more about that?
Absolutely. While there are a bunch of different multiverse theories out there, what sets Deutsch's apart is that it's directly rooted in the equations of quantum mechanics. It's not just speculation, it's a logical consequence of how we understand reality at the most fundamental level.
So it's not like those sci-fi multiverses where you can jump between realities through some kind of portal or something.
Not quite. In Deutsch's multiverse, those parallel histories, they can't interfere with each other. Think of it like parallel train tracks. They might run alongside each other, but they never actually intersect.
That's fascinating, but also a little bit disappointing. No chance of meeting my alternate selves, huh?
Not according to Deutsch. But wouldn't that be kind of overwhelming? Imagine the existential crisis of bumping into a version of yourself who made all these different choices.
Yeah, you've got a point. But it also brings up questions about free will and responsibility. If there are infinite versions of me out there making every possible choice, does my own agency even matter?
That's a question that's been debated by philosophers for centuries, and the multiverse definitely adds a whole new layer of complexity. But Deutsch argues that our choices actually become more meaningful in the context of the multiverse.
Oh, so?
Because every decision we make creates a new branch of reality. We are literally shaping the course of our own universe within this vast tapestry of possibilities.
Wow, that's a powerful thought. It's not about getting lost in an infinite sea of choices. It's about realizing that our actions have real consequences, and that we have the power to create something truly unique.
Exactly. And that's what I find so inspiring about Deutsch's work. It's a call to action, a call to embrace our creativity, our curiosity, our problem-solving abilities, and to see the future as this open horizon of possibilities.
That's a reminder that the journey to the beginning of infinity is just starting, and each of us has a role to play. This has been an incredible deep dive into the multiverse. Thank you so much for taking us on this journey.
It's been my pleasure. Keep those minds curious and keep exploring.
Welcome back, folks. We've been on quite a journey through David Deutsch's mind-bending multiverse. parallel universes, quantum computers. It's been a lot to take in,
It has, but there's one more layer we need to explore, the philosophical implications of all this.
right? We've talked about the science, but what does it all mean? How does the multiverse change how we think about ourselves and our place in the universe?
Well, for starters, Deutsch argues that the multiverse really challenges this idea called reductionism.
Reductionism. Refresh my memory on that one.
Sure, it's basically the idea that you can understand anything by breaking it down into its smallest parts. Like if you know how atoms work, you can, in theory, understand how everything works.
Okay, got it. So how does the multiverse challenge that?
Well, think about abstractions, things like the rules of chess, or mathematical concepts like prime numbers. In the multiverse, these things take on a whole new level of significance. Deutsch argues that these abstractions aren't just human inventions, they're actually real, and they have causal power.
Hold on. Are you saying that the rules of chess exist independently of us out there in the multiverse?
That's exactly what Deutsch is saying. And not just chess, any abstract concept that can actually influence events in the physical world. Think about it. The rules of chess can determine the outcome of a game, which can then affect the decisions the players make.
That's a pretty wild thought. So these abstractions aren't just things we made up. They're woven into the fabric of reality, even across multiple universes.
Exactly. It really challenges that reductionist view that everything boils down to just its physical components. The multiverse suggests there's more to reality than we can see, that these abstract concepts have a real impact on the world around us.
This is seriously making me rethink everything I thought I knew about reality.
And it connects to another fascinating part of Deutsch's philosophy, his incredible optimism about human potential.
You're talking about his idea of the beginning of infinity, right?
Yeah, exactly. Deutsch believes that we are just at the beginning of this incredible journey of discovery and progress, and that there are no limits to what we can achieve. He believes that with the right knowledge, the right approach, we can overcome any challenge, solve any problem.
That's a pretty refreshing perspective, especially in a world where we hear so much doom and gloom about the future.
It is. Deutsch sees our current limitations not as these insurmountable barriers, but as opportunities for growth and innovation. He wants us to embrace the unknown, to push the boundaries of knowledge, and to believe in our ability to create a better future.
It's like a call to action, reminding us that we're not just passive observers in this vast multiverse, but active participants shaping the course of our own reality.
Exactly. And that's what I find so inspiring about Deutsch's work. The multiverse interpretation isn't just a mind-bending theory, it's a powerful reminder of our own agency and potential.
You know, thinking about the multiverse can be a bit overwhelming at times.
I know what you mean.
It's such a vast and complex concept, but it's also incredibly inspiring.
It is. It can be humbling to contemplate the sheer scale of it all, but it also fills me with this sense of awe and wonder. It reminds us that there's so much more out there to discover, so many mysteries yet to unravel.
And that's what makes this whole journey of knowledge so exciting. It's this never-ending quest for understanding, this constant push to expand the boundaries of what we know and what we believe is possible.
You said it. And who knows what incredible discoveries await us as we continue to explore the implications of the multiverse.
It's like we're standing on the edge of this vast, uncharted territory, filled with infinite possibilities, daunting but exhilarating.
It certainly is, and that's the beauty of it all. The multiverse, with all its strangeness and complexity, it invites us to embrace the unknown, to question our assumptions, and to never stop exploring the infinite wonders of reality.
Well said. And on that note, I think it's time to wrap up this deep dive. But before we go, I want to encourage everyone listening to keep exploring these ideas.
Absolutely. David Deutsch's work is full of thought-provoking ideas and challenging concepts. Don't be afraid to dive in and grapple with them. You might be surprised at what you discover.
And remember, folks, this is just the beginning. The journey to the beginning of infinity is just getting started. Keep those minds curious, keep those questions coming, and never stop exploring this vast and wondrous multiverse we call reality. Thanks for joining us.